Hi, Dr. Wang here. Today we're going to work on this math assignment called Master Mix. This is a rather complex calculation. Basically, we are doing all the calculation to assemble PCR reactions from scratch. So we're going to start with question number 3. So in this question, you received primer as powders, and then here 3 numbers provided with the powder. So how do you use the primer powder to make a primer solution? I have already mapped this information onto a CMap. Okay, so starting with powder, and then of the 3 numbers in the question, 89 nanomole is the mass. You're going to add question mark microliter of water to it so that you end up with 200 micromolar primer solution. So here we have concentration, volume, and mass. So solve the volume, and that's the answer for question number 3. And it's basically the same calculation for both forward primer and reverse primer. So the next question is we are going to basically use this 2 solution that we just prepared to make a new solution. So here this is a primer mixture. So we're going to mix up this 2 so that we end up with a primer solution where both primers are at 100 micromolar. So if we look at this branch, we start with forward solution that's at 200 micromolar. We're going to use X microliter of it. So here's our C1, V1. So here's our C2 and V2. So here's how to calculate for this question mark, and this is the answer for question number 4. For question number 5, it's basically the same calculation. You're going to figure out this question mark. So the next question, question number 6, so the amount of water to use. So basically there are 3 potential ingredients: the forward primer, the reverse primer, and water. So the 3 numbers here add up should be 100 microliters. Since you already figured out this and this in question 4 and 5, so you're just going to use this information to figure out this question mark, which is the answer for question number 6. Moving forward, now we're going to assemble the PCR reaction. So that's question number 7. A PCR reaction contains a bead, primer solution, bacteria. So you're going to mix this up, and then that's 20 microliters. So I have this information right here. We're going to assemble a single PCR reaction that's 20 microliter. Within this reaction, the primer concentration should be 10 micromolar. So that 10 micromolar is right here. So there's a bead, right? So we're not going to consider the volume of the bead. That's negligible. And then they also contain a DNA solution, which is basically a bacteria suspension. So if we go to question number 1, we're going to see that the volume of this bacteria suspension is 5 microliter of water containing bacteria. So here DNA 5 microliter. All right, so the remaining 2 ingredients that go into the PCR reaction. The first one is primer. We already made this 100 micromolar solution. We're going to use X microliter of it so that we end up with this solution. So here's our C1, V1, here's our C2 and V2, right? So solve this question mark, and this is the answer for question number 7. So the last ingredient is the amount of water. So there are only 4 things going into a PCR reaction, and the volume should add up to be 20. So you know this is 5 microliter of DNA. You solved this question mark in question number 7. So here you need to solve this question mark, and that's the answer for question number 8. Question number 9. So what about for master mix? Here I have this part for master mix. Master mix contains common ingredients. So those are the primer solution and the water. So for a single reaction, you're going to use this much microliter. So what about for master mix, right? So basically it's going to be this number multiply 11. So that's going to be the amount of primer that you're going to use in the master mix. So that's Q10. And for Q9, similarly, if this is the amount of water used in a single reaction, what about for 11 reactions? How many microliters? So that's Q9. So we have solved most of the questions. Right, so now let's go to the total volume of your master mix. So this is basically these two numbers add up should be the volume of the master mix, right? So that's Q11. And then Q12, the volume of the master mix you will distribute to each of your sample. So here this is basically the total volume, right? So that's basically Q9 plus Q10, the total volume of master mix divided by 11, and then that's the answer for question 12. So now we have solved most of the questions in this assignment. You will probably remember that we haven't solved Q1 and Q2 yet. So coming back to this, the volume of PCR mixture per reaction that does not contain DNA. So that's basically asking the amount of master mix per reaction. So here it's this number plus this number. So that's for Q1. Question number 2, your total master mix volume should be, so hint, it's should be enough for 11 reactions. So this is basically this number in Q1 multiply 11.